What if I told you China has just changed the future of travel? Not tomorrow, right now. Imagine boarding a train that moves faster than a commercial airplane, a train that literally floats in the air while rushing across the country. Countries around the world are still stuck with old rail systems, but China?
Well, a prototype of the maglev, capable of traveling at 600 kilometers per hour.
They're building technology that looks like it came straight from 2050. Today, I'll show you the fastest trains on Earth, including China's mind-bending new prototype that scientists are calling the closest thing to a supersonic land vehicle. And trust me, wait until you see number one. It's unreal. Chinese T-Flight maglev train. Let's begin with a machine that has completely rewritten the rules of ground transportation. China's T-Flight maglev train hits an unbelievable 1,000 kilometers per hour, so fast that a Boeing 737 during takeoff looks slow in comparison. For perspective, a commercial airplane cruises at around 885 kilometers per hour, and this train beats that on land. How does it achieve such insane speed? The secret begins with the fact that the train never actually touches the track. Powerful magnetic forces lift it into the air, allowing it to float smoothly above the rail. With no physical contact, there's zero friction, which removes the main barrier that slows down traditional trains. It's essentially like firing a bullet through a magnetic launcher, except the bullet is a passenger train. But the real breakthrough comes from the use of vacuum tubes. Imagine this: ordinary trains constantly battle air resistance. The T-Flight, however, travels inside a near-airless tunnel. With almost no air to push against, the train can accelerate to extreme speeds, similar to how spacecraft travel effortlessly through the void of space. The result is jaw-dropping. This ultra-fast system can connect Beijing to Shanghai in under 2 hours, a trip that currently takes 4.5 hours, even on the world's fastest high-speed trains. There's no doubt this technology is redefining what it means to travel on land.
Shinkansen E5. The Shinkansen E5 isn't just a train, it's a masterpiece of engineering that has stunned the world for decades. As Japan's fastest commercial bullet train, it reaches 320 kilometers per hour, but its true greatness isn't defined by speed alone. What makes it unbeatable is something no other railway system on Earth has managed to match: absolute, almost supernatural punctuality. The E5's average delay is just 18 seconds per year. Yes, per year. Every component is engineered with mathematical precision, functioning together like a perfectly tuned Swiss watch racing down steel rails. Its advanced automatic control system uses AI to detect and correct potential issues before they can even occur. And the maintenance standards are so extreme that parts are replaced long before they ever show visible wear. The result? Over 60 years of operation without a single fatal accident, an achievement unmatched anywhere else in the world. But what's even more remarkable is the tech under the hood. The E5 uses a regenerative braking system so efficient that it can actually generate more electricity than it consumes while descending. When other countries build high-speed trains, they aren't only competing with Japanese engineering, they're competing with 6 decades of flawless performance and a legacy of perfection the world has never been able to surpass. The CR2-380A. The CR2-380A is the machine that proved China no longer needs to copy anyone in railway technology. This beast reaches 420 kilometers per hour in official tests, a speed so extreme it left engineers around the world stunned. Its sleek aerodynamic body takes inspiration from fighter jets, with a long, razor-sharp nose that slices through the air like a blade. But the real madness isn't its top speed, it's its endurance. This train can cruise at 350+ kilometers per hour for hundreds of kilometers without overheating, slowing down, or suffering mechanical stress. The secret is its revolutionary cooling system, which uses liquid air to keep its engines at the perfect temperature even after hours of full power operation. What truly sets it apart is that it can be powered continuously while in motion, removing the need for long technical stops. This allows the CR2-380A to cover routes that would normally require domestic flights, all while maintaining speeds that rival small aircraft. China has essentially created an unstoppable railway machine capable of traveling long distances at extreme speeds that many countries still consider impossible for ground transportation.
The CR380D. We have the train that marked a turning point in China's railway history. The CR380D was the first high-speed train designed and built entirely with original Chinese technology. While older models relied on German and Japanese foundations, this machine is 100% Chinese engineering from the ground up. Its most surprising feature? Silence. While most high-speed trains roar past like fighter jets, the CR380D glides by like a ghost. You can stand near the tracks and hear almost nothing as it slices the air at 350 kilometers per hour and beyond. Its iconic dragon head isn't just a cultural symbol, it's a masterpiece of aerodynamics. That long, curved nose reduces air resistance so efficiently that it nearly eliminates sound altogether.
Chinese engineers achieved what many thought was impossible, combining ultra-high speed with near-total quietness. With world-class performance and unmatched silence, the CR380D proved China no longer needed foreign designs. It signaled the beginning of a new golden era of Chinese railway innovation. Low Zero Series Maglev. Japan has once again rewritten the rules of rail transportation with the creation of the Low Zero Series Maglev, a technological marvel capable of reaching a staggering 603 kilometers per hour, a speed that pushes the limits of what we thought was possible on land. Although not yet in commercial service, the Low Zero is expected to launch around 2027, and when it does, it will completely transform high-speed travel. What makes this machine extraordinary is its superconducting magnetic levitation system, which allows the train to float 10 centimeters above the track, never touching anything. No wheels, no friction, just pure, silent levitation. Its suspension technology is so advanced that it maintains perfect stability even at speeds past 600 kilometers per hour, a feat engineers once believed could never be achieved. The impact on travel time is mind-blowing. The Low Zero will cut the Tokyo-Osaka journey to only 67 minutes, compared to the current 2 hours and 15 minutes on the fastest Shinkansen. By eliminating contact with the rail, the train removes both friction and mechanical wear, making speeds unreachable for traditional trains. Combining Japan's world-leading safety standards with unmatched velocity, the Low Zero series stands as a glimpse into the future of transportation. With its futuristic design, magnetic levitation, and record-breaking performance, this train is poised to redefine how humanity moves across the planet.
Germany's ICE-3 is Europe's fastest high-speed train and a proud symbol of the nation that pioneered magnetic levitation technology. In testing, this engineering marvel has reached 368 kilometers per hour, though it operates commercially at a controlled 300 kilometers per hour to ensure maximum passenger safety. But what truly sets it apart isn't just its speed, it's the groundbreaking safety systems that make derailment almost impossible. The ICE-3 uses distributed traction, meaning multiple powered axles work together to deliver smoother acceleration and stronger braking. Its active tilting system allows it to glide through curves at speeds that would immediately throw other trains off the tracks. A network of advanced sensors continuously analyzes rail conditions, adjusting the train's balance in real time to maintain perfect stability. German engineers pushed aerodynamics to an almost obsessive degree. Every contour, every panel, and every surface has been mathematically refined to slice through the air with minimal drag. Even the wheels and chassis are made from specialized alloys capable of enduring decades of high-speed travel without warping or excessive wear. The result? A masterpiece of precision engineering. The ICE-3 is a train built to maintain extreme speed, incredible efficiency, and flawless safety for decades, redefining what the world should expect from modern rail technology. Italo AGV. Italy's Italo AGV is redefining high-speed travel in Europe, reaching an impressive 360 kilometers per hour and operating commercially at 300 kilometers per hour with a level of efficiency that has stunned engineers across the continent. Serving major Italian cities, this train has become a symbol of innovation, style, and world-class engineering. What truly makes the Italo AGV stand out is its locomotive-free design. Instead of housing all its motors at the front, the train uses distributed traction, spreading power across multiple cars. This not only boosts acceleration, but also frees up more interior space, giving passengers a more comfortable and spacious ride. Built with ultralight composite materials, the Italo reduces overall weight dramatically, allowing lower energy consumption and higher top-end performance. Its advanced suspension system absorbs nearly all vibrations, delivering an exceptionally smooth experience even when traveling at maximum speed. The Italo AGV proves that when cutting-edge aerodynamics, next-generation materials, and intelligent engineering come together, the result is a train that is not only fast, but incredibly reliable. Who would have imagined that Italy would create one of Europe's most advanced and record-breaking private high-speed trains? Shinkansen Alpha X. Meet the train that looks like it came straight from the future. The Shinkansen Alpha X is a 10-car, 320-meter experimental machine pushing the very limits of what rail technology can do. In testing, it has already reached a staggering 400 kilometers per hour, rewriting the rulebook for high-speed transportation. What makes the Alpha X truly extraordinary is the technology packed inside it. As it races along the tracks, the train constantly analyzes over 10,000 data points in real time, monitoring everything from external temperature to micro vibrations. This constant stream of data allows it to travel at extreme speeds with unmatched precision. Its most iconic feature is the 22-meter needle-sharp nose, shaped like the tip of a spear, to slice through the air with minimal resistance. But here's where it becomes revolutionary. The Alpha X can adjust its own shape while moving. Sensors embedded across its body detect wind pressure, airflow changes, and environmental shifts, automatically modifying its posture to maintain maximum stability and aerodynamic efficiency. Even its safety systems are next level. The Alpha X can come to a complete stop from 400 kilometers per hour in just 2 minutes, outperforming every international safety benchmark. Japan plans to introduce this futuristic marvel into commercial service by 2030, setting a brand new global standard for high-speed rail. This is the new reality of transportation. From magnetic levitation trains that float above the tracks to experimental machines approaching the speed of sound. The real question now isn't if these trains will replace airplanes for medium-distance travel, it's how soon and whether the rest of the world can keep pace with this level of engineering brilliance. Which one of these next-generation trains blew your mind the most? And tell me, would you dare to travel at 1,000 kilometers per hour on land? Let me know in the comments, and don't forget to subscribe for more incredible content.